Hello students, in today's video I will be discussing the concept of mean and variance regarding the gamma distribution. So students, before starting the concept of mean and variance of gamma distribution, we must know that which type of the distribution is gamma distribution. So gamma distribution is a continuous distribution. It is known as a continuous distribution. So if it is continuous distribution, so it must be having a probability density function. So what would be the probability density function of this gamma distribution? It is denoted like fx semicolon alpha and beta. So what do we mean by these alpha and beta? Here these alpha and beta are two parameters. So which is defined like this one: 1 upon beta to the power alpha into gamma alpha into x to the power alpha minus 1 into e to the power minus x upon beta, and this will exist for x greater 0 and otherwise its value is 0. So and here alpha is greater than 0 and value of beta is also greater than 0. So this is probability density function for this gamma distribution. Now since we are having this probability density function, so now we can move ahead towards the mean of the gamma distribution, and we know mean is nothing else but expectation of x. So how we can write it? 0 to infinite x into associated probability density function. So that is 0 to infinite x into, and what is the associated PDF? This one, that is 1 upon beta to the power alpha into gamma alpha x to the power alpha minus 1 into e to the power minus x upon beta dx. So this 1 upon beta to the power alpha into gamma alpha is a constant term, so I can take it before the integration. So it would be 1 upon beta to the power alpha into gamma alpha into 0 to infinite x into x to the power alpha minus 1 and e to the power minus x upon beta dx. Ultimately it is 1 upon beta power alpha into gamma alpha into 0 to infinite x to the power alpha into minus x upon beta dx. So here how to solve this particular integration? In order to solve this integration, I will be considering x upon beta is equal to t, or which implies x is beta into t, or which implies dx is beta into dt. So it would be like 1 upon beta power alpha into gamma alpha, and this limit will be unchanged, 0 to infinite. This x is now beta into t whole power alpha, and it is e to the power minus t, and here it is dx is beta into dt. Ultimately this beta power alpha and this beta power alpha will be cancelled out, and I can write it beta upon gamma alpha and 0 to infinite e to the power minus t to the power alpha dt. Students, there is a concept of gamma function which can be discussed with the help of one formula, that is gamma alpha is 0 to infinite e to the power minus x power alpha minus 1 dx, where value of alpha is greater than 0. So what I can do here, I can write it like alpha plus 1 minus 1. So it would be like this one, t to the power alpha plus 1 minus 1, and easily we may write it beta upon gamma alpha as it is, and this whole term will be now equal to gamma alpha plus 1 by using this particular formula. So and one more formula is here, that is gamma alpha plus 1 is alpha gamma alpha. So I can write it beta upon gamma alpha into alpha gamma alpha cancelled out, and alpha into beta. So students, this is known as the mean of gamma distribution. Now after finding out the mean of gamma distribution, now we can try to find the variance of gamma distribution, and variance is just expectation of x square minus expectation of x whole square. So this particular value we are already having with us. Now we will try to find this particular value, that is expectation of x square. So it would be like 0 to infinite x square into associated probability density function, or it is 0 to infinite x square into, and PDF is just like for gamma distribution, equal to 1 upon beta power alpha into gamma alpha x to the power alpha minus 1 e to the power minus x upon beta dx, or it is 1 upon beta power alpha into gamma alpha 0 to infinite x to the power alpha plus 1 into e to the power minus x upon beta dx. What we can do here, now I can consider here again x upon beta is equal to t, that is x is beta into t, or that is dx is beta into dt. So the limit will be unchanged. It would be 1 upon beta power alpha into gamma alpha 0 to infinite. This x is now beta into t. So beta into t power alpha plus 1 and e to the power minus t into beta dt. So what we are going to get here, this beta power alpha and beta power alpha will be cancelled out. Ultimately beta square by gamma alpha 0 to infinite e to the power minus t to the power alpha plus 1 and dt. Now again I will be try to utilizing here this particular formula of gamma function, that is gamma alpha is 0 to infinite e to the power minus x power alpha minus 1 dx, where alpha is given greater than 0. So here what I will do, I will add 1 and subtract 1. So ultimately it is beta square by gamma alpha 0 to infinite e to power minus t to the power alpha plus 2 and then minus 1 dt. So by utilizing this formula, it may be written like beta square by gamma alpha and then gamma alpha plus 2, gamma of this alpha plus 2, or it may be beta square by gamma alpha and then gamma alpha plus 2 is like alpha plus 1 gamma alpha plus 1, or it may be written like beta square by gamma alpha as it is, and it is alpha plus 1, and this gamma alpha plus 1 is alpha gamma alpha cancelled out. Ultimately it is alpha plus 1 into beta square. So here we are having the value of expectation x square. Now on the basis of this expectation of x square and value of expectation of x, we can easily find the variance, and which is expectation of x square minus expectation of x whole square. So I am utilizing this value here. This value is alpha plus 1 beta square, and this expectation of x, this value we have already evaluated, mean that was alpha beta. So I will be utilizing this value here. So it is going to be, students, alpha into beta whole square, that is alpha square beta square plus alpha beta square minus alpha square beta square. It is cancelled out. Ultimately it is beta square. So this is a final value of variance. So what is the crux here? Crux here is that mean of the gamma distribution is alpha beta and variance of the gamma distribution is equal to alpha beta square, where alpha greater 0, beta greater 0 for mean, as well as alpha greater 0 and beta greater 0 for variance. Students, I hope that this video will be very useful to all of you regarding mean and variance of gamma distribution. Thank you so much for watching this video.